Okay, so this work is not going to be done inside the green packet. I prepared a separate packet that basically has 2 sheets of paper, should be copied front and back, and they are summary sheets. And basically what I'm going to do is I'm going to take all the information that we've been working on, some stuff from chapter 2 as well as stuff from chapter 3, and kind of condense it and put it all together. So we're going to start out with at rest. So before we get started with all of this, let's just take a moment and think about what happens. What does it mean when something's at rest? So you might say that the position doesn't change. So that means whenever you look at it, the position is the same as it was the last time you looked at it. It could be anywhere. It could be at the 0 reference location, whatever you've deemed that to be, or it could be 10 meters away in the positive direction, or it could be 100 meters away in the negative direction, but it doesn't move. So what is the velocity equal for something that's at rest? And what is the acceleration equal for something that's at rest? So hopefully you recognize that if something's at rest, the velocity is 0 and the acceleration is 0. So what we're going to do is we're going to fill in this at rest summary sheet. And we're going to kind of go through it and take a look and see what we can compile based on everything that we know so far. So I've got a table of data here, and at any time you should be able to put in a distance, and it really doesn't matter what number you choose. I ended up choosing 2 just because. But it needs to be the same distance for every time interval because this thing is at rest. It's still sitting there. I like to choose something other than 0 just to help me remember that it doesn't have to be at the 0 point. And so the distance graph is going to be a straight horizontal line at whatever value that you selected to put in your table. And your velocity graph over here is going to be a straight horizontal line at 0 because the velocity is always going to be 0. It's at rest. It's not moving. So you're going to end up with something that looks like this. So you should have velocity equals 0, a equals 0, some distance. Doesn't really matter what it is. And your velocity should be 0 all the time. Now, all of this should hopefully be relatively common sense, okay? So we can graph distance versus time or position versus time, and anytime we have a flat, straight, horizontal line, it's going to be at rest because it's not moving. Anytime you have a velocity versus time graph that shows a horizontal line right here on the 0, it's also going to be at rest. Okay, so these are kind of characteristics of graphs. We're going to be looking at graphs, and I'm kind of filling in these summaries here for you to recognize that you understand this information, and now it's just going to be applying it. So looking at the forces. So what do we know about forces when an object is at rest? Back in chapter 2, we talked about balanced and unbalanced forces. So hopefully you recognize and remember that if the object is at rest, it has balanced forces, and that the net force equals 0. And what type of equilibrium do you have? If it's at rest, it would be static because it's standing still. And then based on this information, what kind of forces could you see on the free body diagrams? Well, you have to see balanced forces, right? They have to be balanced in opposite. They have to be equal in opposite directions. So for this is what I have. So I circled balanced, net force was 0, static equilibrium. I've got balanced vertical forces. I've got balanced horizontal forces. And here my arrows don't need to be equal on each side, and they really aren't, even though they kind of look like it here. But the vertical forces are equal and opposite, and the horizontal forces are equal and opposite. So all of this is stuff that you know and that you've seen, and we've been practicing. So nothing here is new. And I also want to let's take a look at these ticker tape or oil drop diagrams. So for an object at rest, we normally put motion and motion arrow. So if an object was at rest and it was starting over here on the left, what would it look like? It would be one drop right there, and it would probably get bigger and bigger the longer it sat there. The same thing would be true as if it started over here on the right-hand side. It would still be one dot. So you should end up with something like this. So this is what you would have for your summary sheet if you had an object that was at rest. So you're going to want to have filled all this out. I'm going to separate the videos by each page in here so I can do the constant velocity on the next video. Here is what my overall summary sheet looks like. Okay, I will do constant velocity on the next video.